Welcome to Flip Math Lesson 22 for the 5th grade. Today we're talking about division with and without remainers. So we'll be looking at two different ideas. We can start with our word problem here, which says 60 Pokemon cards are being sold at an auction. If the sellers sell cards in groups of 8, how many packs of Pokemon cards can be sold? And then we also want to know how many cards will be left over. And so we can start by looking at this. We know we want to divide these into groups, and we know we want 8 cards in a group or 8 cards in a pack, and we know that there are 60 total cards. So if that's our total of 60, and we're going to divide them into groups of 8, we're going to be going 8 into 60. And we can start solving this, right? 8 goes into 6 0 times. 8 goes into 60. We got to think hard about our math facts. We know that 8 times 7 is going to give us 56. And so we're going to have a remainder of a 4 then. And that allows us to find really both answers to our question. First of all, it says how many packs of Pokemon cards. So you could sell 7 packs of cards because 7 times 8 gives us 56. And so we can get 8 full packs. And how many cards are going to be left over? There's our remainder sitting there. And so the second question are 4 cards remain. And so we have these two ideas. We used the information and we did some division to get us our 2 numbers. All right, let's try another one. All right. This one's going to go ask you a number of different questions as we apply this information to division. It says at a hot rod event. That's a fancy car for those who don't know what a hot rod is. 23 people are waiting in line for a ride in an old-fashioned hot rod. A hot rod can hold 3 people. So those are the facts that you are given. Question A says, what is the least number of hot rods needed at the event so everyone can ride at the same time? So everyone can ride at the same time, right? So we're going to start by looking at this idea. If we have 23 people, and to fill up a hot rod, we can put 3 in a vehicle at a time. We're going to see that 3 goes into 2, 0 times 3 goes into 23. It's going to be 7 times. All right. And I'm going to move this out of the way so you can see what we're doing. And so 7 times 3 is 21, and we have a remainder of 2 people. However, while we have a remainder of 2, the question says that we want everyone riding at the same time. And so we for sure need the 7, we see that. But because we want everyone riding, we want these 2 people in a car also, which means even though 3 does not go into 23 evenly, we're actually going to need 8 hot rods so that everyone can ride. In this case, the last hot rod is only going to have 2 riders instead of 3 riders, though. So we have our first look at what's going on. Next it says, if 5 hot rods show up, how many people will have to wait for a turn, for a ride? So we got to go back to our original problem. We know that there are 23 people waiting, and we know a hot rod can hold 3 people. In this case, we're going to use a number of different things to find this answer. First of all, we need to figure out how many people 5 hot rods can hold. And since 1 hot rod can hold 3 people, all right, so 1 times 3 we know that 5 hot rods times 3 people is going to give us a total. 5 times 3 is 15. From there, we can now take our total number of people, which was 23, and we can subtract that 15 people who are going to be able to ride right away. And so we're going to subtract 23 and 15. And so to get that 3 out of there, we're going to borrow to make that 13. 13 minus 5 is 8, and 1 minus 1 is 0. And so in the end, 8 people will continue to wait. So we have that idea. Finally, we can go back to a similar idea in letter C. It says if 8 hot rods show up to the event in total, so there are 8 total hot rods. It says how many hot rods will be completely full? Will be completely full. Once again, we're going to go back to our problem since there's 23 people and 3 people can fit into a car. Now this time we want to know exactly how many cars are going to be full. And so once again, we're going to plug this information in. 3 goes into 23. We already know that it goes in 7, 21. So we have that, and we get our remainder of 2. But now this time it says how many cars are completely full. Not how to get everyone in, but are completely full. And so this time as we're reading this information, we know that 7 cars are completely full. And so while there are 2 people remaining, 7 of the cars are completely full. And so that answers our question. So 7 hot rods will be full. And so we're starting to see division, how different types of questions can be used in division, and what that means. Now sometimes division has some tricks that we can follow. We want to be able to divide these numbers, or at least say, is there going to be a remainder or not? And we can look at a couple different tricks. Later on, we're going to call this the last digit rule. And by looking at the last digit, we have a couple of different things that we can look at. We can start with the number 2 over here on the left. Number 2 is a number that is very easy to divide. All right. We know that if a number is even, all right, and specifically if this last digit is even, it's going to be divisible by 2. And so as we look at the problem in front of us, we want to look at the last digit. That's a 9. The question is that even or odd? And of course the answer is odd. And so that means that this is not. So the answer to this is no. Or this problem will have a remainder, right? It is not divisible by 2 evenly, and so it will have a remainder. If we were to do it, 2 goes into 19 9 times, and it's going to give us a remainder of 1. Another last digit rule that we can look at is dealing with 5s. All right? 5s, if a number is divisible by 5, it's going to end in a 5 or a 0. Guaranteed, right? You can count by 5s, 5, 10, 15, 20, and it always works in that way. And so as we go to this one, we can look at our last digit, and we can see that it ends in a 5, and so that means this 5 is going to evenly go in. And so there will not be a remainder. All right. Maybe we should just write no remainder. That's better English. All right. In that case. All right. If we look at another 5 problem over here, all right, we can say, okay, what's the last digit? It's a 1. Is it a 0? Is it a 5? No. That means there will be a remainder. 5 is going to go into 41 8 times. That's going to be 40, and so we're going to have a remainder of 1 in this case. The last very easy digit rule that we can follow is looking at the number 10. All right, because the multiples of 10 will always end in a 0. All right, and so if we're dividing by 10 and we want to evenly have this, we know it's going to go in perfectly. So 10 goes into 30 perfectly. All right, and 3 times. So there will not be a remainder. But if we had 10 going into 52, we can see that this last digit is not a 0, which means there will be a remainder on a problem like that. And so some things to think about as we work with division. All right, I'll leave you with a sample problem, and you can work through this, showing how division works with this idea and the relationship with remainers and not having remainers. That is flipped lesson 22.